Okay, for this next problem we want to find the limit, and then we want to explain what this result will mean about the graph of a rational function. So, if we want to find the limit, remember we can always just do direct substitution first. So we want to plug in the -1. But when you do that, you're going to get 0 in the denominator. Okay, so we want to try to factor here. So two things that multiply to 1 and add to -1. So that's not going to work out. So we can't factor the top part. You can factor the denominator. You could take out a 2 and make that be x plus 1. But regardless, nothing's going to cancel here. So because we are coming in from the right here, we know that x equals -1 is a vertical asymptote because it's left over in the denominator. And so we can figure out the left and the right side. You just have to plug in a number. In this case, we're going to plug in a number that's bigger than that. So be careful with the negatives. If we want to plug in a number that's bigger than -1, we could plug in -0.9. Alright, so we're going to plug that in. So everywhere there's an x, we're going to plug in the -0.9. And then all we care about if this is positive or negative. So this -0.9 squared will be positive. This will turn into positive, and this will be positive. So all of these are positive. And then in the denominator, this will be positive times a positive 2, so this will be positive. So this is going to be positive. So that means that the limit, as x approaches -1 from the right here, is positive infinity. Okay, so if you remember when we had that existence justification, it said anytime we have a limit from the left or the right, and it gives you positive or negative infinity, that tells you that value with x is going to be a vertical asymptote. So this means that x equals -1 is a vertical asymptote. Now the way I taught you how to do this, we've already been talking about these are vertical asymptotes just to get to this point here. And I do that just to reiterate here. But we're just proving here that if you come up with a limit for the left or the right of a number, and it gives you infinity or negative infinity, that means that this x value has to be a vertical asymptote. So that just confirms that. Okay, so for the next part, we're going to be doing some more limits at infinity. We're going to be doing these, so no calculator, we're just going to be thinking about what the graph would look like. So limits at infinity are when it's asking you the limit as x approaches infinity. So in other words, thinking about the end behaviors. And the easiest way to think about end behaviors is with the graph. So if you remember when we did the limits of the exponentials, we were using the graphs there. Okay, so this is just a cubic function. So in pre-cal and in Math 3, you talked about how you could sketch the graph of polynomials without having to use the calculator to get the end behavior. So what you do is you take the highest degree, so that would be the highest exponent. So we're only going to look at this term right here. And you're going to look at the degree or the highest exponent and see if it's even or odd. So this is odd, so that means it's going to be odd shaped. And then you're going to look at the coefficient out front and see if it's positive or negative, and it's negative. So odd shape means that one side's going up, one side's going down. If it would have been even, they would be going the same way. So because it's negative, it's going to fall. So the graph is going to look something like that. Okay. So now that we have a little sketch of the graph here, we're doing the limit as x approaches infinity. So that is your right end behavior, which is here. And because that is going towards negative infinity, that is what the answer to your limit is going to be. Okay. So for any polynomial, you look at the highest degree. If it's odd, it's going to be odd shaped, so one going up, one going down. If it's even, they're both going to go up or both going to go down. Negative, you're looking at the leading coefficient. Because it was negative, odd shape will fall. If it would have been positive, then that odd shape would have rise from left to right. And then even, if they're positive, they're both going up. Even if it's negative, they're both going down. So you can sketch the graph there. Alright, so next one here, we're doing the limit as x approaches negative infinity. So we're doing the left end behavior. So You can multiply this all out if you want to get your polynomial, or because all we care about is the highest exponent, we can just multiply out what the highest exponents would be. So if we were to multiply this out here, we would have this negative x squared. If there's a negative with the x, you have to keep it, okay? We would have just an x here, and we would have just an x here. So the negative x squared would become a positive x squared. So we have x squared times x times x. So we would be looking at x to the 4th here, and that's positive. So same thing. This is an even degree, and it's positive out front. So even and positive means that they're both going to be going up. So our question says the limit as x approaches negative infinity, so that would be your left end behavior. Should be here. So the limit as x approaches negative infinity, because that side is going up, would be towards infinity. Okay, and then this last one here, we have a rational function. So we're just going to kind of sketch the graph here. So rational functions we know have asymptotes. So because it says x plus 3, we have a vertical asymptote at x equals negative 3. And then if you remember, for horizontal asymptotes, they have the same degree, so you're going to use the coefficients. So it would be negative 2 over 1, so your horizontal asymptote would be at negative 2. So let's just sketch this. Okay, so there are ways you can plug in to see where this graph's going to be located, but we only care about the right end behavior here. So we only care about this end behavior here. So the graph will either go like this, or the graph will go like this. It's not going to do both, but it's going to do one of those two on this right end behavior. Regardless, either place this is going to go, this graph is always going to go towards that horizontal asymptote. So that means that right end behavior is going towards that negative 2. So that limit as x approaches infinity of this would be negative 2. Okay, if they would have asked us for the left end behavior, it would have been the same thing. They're both going towards, no matter where the graph is, they're both going towards that horizontal asymptote. Okay.